Hey everyone, welcome back to the channel. Still working on the old Corvair fuel injection stuff. And in this video, well, I'm going to share how I did the crank trigger in this thing. Hopefully I give you enough details that doesn't matter whether it's on a Corvair or not, you'll be able to handle putting it on any vehicle. First thing I'm doing is I want to make sure that I get this crank trigger on, and the reason for that is I want to be able to turn this engine over with a wrench to be able to work on the rest of the stuff. So what I have here is the crank pulley, and the original plan was to take this, cut this off, and use this as a spacer. Now, first point, this pulley is not going back on. We don't need it. So I talked to my Corvair guy and I asked him, why do they have, is this balance marks just because the casting on this was so poor to balance it? And he said, yeah, I couldn't imagine why they would have that much on for balancing the engine. And he said, to me, it doesn't really matter anyways, because he has the equipment to balance this anyway. So when it comes back, we're going to have a balanced engine. So I'm going to be sending the engine with a crank trigger. And how I knew this isn't going to work, because it isn't going to work. Because what happens is if I use this little bit of a spacer, my crank trigger would be too close to the crankshaft, and I wouldn't, or to the harmonic balancer, and I would not be getting a good reading, because there's a chance that my signal would be picked up by the edge of the crank pulley. So what I did to test that theory is, this is a rare earth magnet. These nuts are the correct thickness, same thickness as this flange. And so just threw on some rare earth magnets, set it up. Okay, those do go over there, but they are so strong. I set it up, put it on there, and yeah, it's definitely too close. So I have to make a new thicker spacer. I am in the process of milling down a piece of stock now for that crank spacer. So I have the outside chewed up, both ends chewed up. I have a little collar for the indent that goes into the end of the crank. And I'm just lining up the center of where that crank bolt is going to go. And I probably went a little overkill with the material I'm using. It's actually 4140, but it's what I had on the shelf in the closest to diameter. So I need to order some more materials to have it on the shelf, because it's a little bit more money. And it doesn't need to be 4140. So the pilot started. I've taken a boring bar here and I have bored that out, and the purpose is so that I have the same thickness of here down in the bottom of that. And you can see the little collar on there, same as what is on there. And the reason for that is I can take the crankshaft bolt now and put it in the same depth, and I know that it is going the same amount, and an impact socket also fits in that. I've taken a look, and this now, there's extra meat here. I can take some off, and what my plan is to, first of all, this is the bolt circle, and on here I'm going to be drilling through 3 bolts. One of them is going to be acting like a lineup dowel, and we're going to have this marked to where the timing marks are on the car. So having said that, I'm going to machine this down and have this bored out so that it fits over a lip onto here. All right, I am really pleased with how this turned out. So this is our hub spacer. Again, the distance that this is machined in is very close to the thickness of the pulley, the crank pulley that was on there. These holes definitely line up with the holes down here, these 2 holes. The only problem with this is this can be rotated either way. And so our marks could be 180 degrees out. So my simple solution, and it should be self-explanatory, is I took a 70 thou bit, drilled a hole in, and this little piece here is 3/8. It's a 3/8 long roll pin, so it just goes in a tiny little bit, sticks up. And then when I lined up this, this all goes together, and that little roll pin will hold that. And so that I understand, or whoever understands, I just punched in here so balancer, timing, mark. So when this lines up, the timing mark on the balancer is right there. So my 36 minus 1 tooth wheel, it lines up only one way then. If I'm putting this together, I don't need to worry about anything. And realistically, the dowel pin I wouldn't have needed to put in there, but it is sure nice to be able to have this stay together when you are putting it in. And so, and that bolt in the bottom, if the mount was off, wouldn't need to worry about the length of that bolt. But I wanted this serviceable in case something needs to be serviced in the car, which I guess it doesn't really make sense that is could happen. So, but everything lines up beautifully, and we end up with a good space in here. So when we put our sensor in, I'm not going to be fighting with picking signals up from anywhere else. This is going to be a pretty clear-cut signal for that sensor. And yeah, I'm just going to tighten this up, and then I got to get that distributor drive stuff built. So that's going to be the next step for that. Okay, we have the crank trigger wheel on there. It's a 36 minus 1, like we've already talked about. I think I've said that before. Now this right here is where the fuel pump used to be driven off, and I need to plug that so it isn't an oil leak. But what I'm going to do is I'm going to take advantage of this. I'm going to build a plug that goes into here that has a bolt hole in it, or enough that we can weld on the top, because I'm going to need to mount this sensor. So this is actually the sensor that I'm going to be using, and I'm going to have to make it adjustable and so on in here. So I'm not sure exactly how I'm going to do that, but I am going to start on making a plug with a bolt hole in it, and I will show you that. I just have a piece of hot roll in there, and I'm machining it down. What I'm going to do is I'm going to take, and this much is going to be stepped out. This is going to go into the block, and I need to put an O-ring. Actually, it's not into the block, it's into the adapter for the front of the engine, but bolts on. Anyway, I'm going to cut in an O-ring groove into it where it needs to be, and then we can put a hole in this side here that will allow for that adjuster or the lock pin for the fuel pump to go in and lock this in place, which is going to be a great holder for that. So I'm going to reuse that stuff, and then I'm going to drill into this, but not all the way in, so that I can thread the hole and it won't be a blind hole. If I did drill all the way through, I could just weld the end up, but I'm going to try and not do that. Okay, I just got to finish parting this off. I'll just show you what I got here. So I machined this down, and I machined a step in there. I don't know if you can see, there's a step plus this O-ring groove. That little black line there is where the old fuel pump holder hole is going to be drilled roughly. I'm going to put this in and then drill it. That little step there is the taper where the fuel pump went into. Let me take you over there and show you that. So this is the taper that I'm talking about, and you can see there's a hole right there, and this is where that fuel pump holder went. So we will just duplicate that in there when we get it dropped in. So I have the plug almost made, and I just thought I'd give you a little detail. So this, I started threading in the lathe, and what I used is a power tap. So these you can buy, basically you can go in a drill press, in a drill, whatever, and drill it. And these taps are made to tap in one direction. I only went in a little ways because I have not drilled this all the way through. So started with a power tap, just enough to get it really straight in the lathe. And then I am going in with a bottoming tap right now. And so bottoming tap, I'm not going to pull it out because I'm in a long ways. Basically, the threads start right at the end and they're square. And that way you can tap right to the bottom of the hole you drilled. On occasion, you get a little overzealous. And guess what I did? I broke the tap off. Taken lots of broken taps off. So years ago, I broke this chisel off and I grind it down and sharpen it and get it nice and hot and quench it. And literally, I'm not going to set the camera up, but I fairly quickly can get this tap out by getting in here and just slowly tapping around on the edge and turning it out. The top of the hole, I'm going to put it in and chamfer it, but this hole I can save. And it's just from experience. The thing when you're doing this, yeah, it's going to add probably 15 minutes to the job. I guess I get to eat that and as well the punch or the tap. But you take your time, you get it out. Otherwise, I'd have to probably eat, I don't know, 3/4 of an hour by the time you make this thing. So, I don't know. Life is what it is, and it really sucks I did that. And that's just me trying to be too fast. Me getting a little over anxious. If I would have just slowed down, blew the hole out, took the tap out, cleaned it out, would have taken me 2 minutes longer to save. Well, I thought it'd be 15 minutes, but this is probably more like 8-10 minutes to recoup this hole and a tap. But not always worth it to just rush and give her. And that would have sucked if this would have broke up. That would have been a pain to get out because she's in there pretty deep. But bottom of the hole is full of filings, and that's what I did, is I went a little stupid. Anyway, we are good to go. That is sweet. So I took a bottom tap, another one that I had, tapped it out the rest of the way. And I'm just going to dress this top end, even though it looks pretty nice. I just don't want it to look like anything ever happened. So beautiful. Just got to clean it up. She's fixed. The little plug is done. I have the O-ring groove in. I already put the old O-ring in and tested it. It fits beautifully. I have that bolt hole in the top. It doesn't go through. And this little hole lines directly up so this pin can hold it in place. This is aluminum. This is steel. This is going to be subject to road grime and so on. And I made this thing a little on the loose side. And the reason I did that is because I want to prevent galvanic corrosion. What galvanic corrosion is, I'm not going to get in deep, but basically we have two dissimilar metals that can corrode and cause problems. You would have a real hard time. You'd have to use a slide hammer to get this out. So this is getting powder coated because we're powder coating a whole bunch of other stuff. It's not a big deal. Anyway, now I have a piece that dual purpose plugs the fuel pump hole and has a mount for where I build the crank sensor. Okay, just trying to keep you in the steps. Basically, just taking a piece of pipe. This sensor is going to go in there fairly loose. I just cleaned up the outside of it. Ran a reamer through the middle to take the welded seam out of it. You can see that in there. And this is a 3/4 reamer, 3/4 inch Sked 40 pipe, or yeah, Sked 40. And I'll be sectioning it off. I have enough for both the cam and crank sensor on this one. Okay, I took a piece of flat here and just bent it around, kind of made it a little bit long. Then I CNC'd out this piece. In the last video where I was machining this, you can actually hear the CNC running in the background. So the top is CNC'd out to hold the sensor. This is all tacked together. I got another piece that I CNC'd out here that is going to get welded on, and then I will take and grind off the extra. I made it a little bit big, but with this one here, I actually, the spec is 1 mil to 5 mil, so I am not making this one adjustable. I'm actually putting it at, well, it's landing where the sensor in here is going to be about 1.2 mil. And if it needs to go a little bit further away, we can add shims underneath this. Well, here's the crank sensor bracket welded out. Once it's sandblasted and powder coated, it should look pretty good, and it's going to work great. I will work at getting that assembled. Thanks for joining me as I figured out the crank sensor here, and I think it's turned out pretty good. And I will get this all powder coated up the next time you see it. We'll probably be trying to get it programmed into the ECU. Anyway, thank you so much. Please like, share, and subscribe.